So a bit of research going on into the HCH2 inverter. I've now made up a gizmo to display me the serial data being passed between the dumb part of the inverter and the motor control module, which is built into the inverter. And I've also got it, this device, looking at the CAN data which is coming out of the inverter on the IMA CAN and the F CAN. And we've got two sort of voltages coming out, and I'll show you those in a minute. But there's basically a 16 byte packet going from this high voltage side of the inverter. There's a serial, some optos here, so I've just clagged onto the low voltage side of the opto isolator, which is the motor control module side here. So this is the serial data. It's being passed from this little module here to the motor control module. In the Insight and HCH1, these are separate components, so it's easy to sort of piggyback and hack into this. But with this, we actually had to find it on the board here and do it this way. So if we wanted to actually manipulate this data, we'd have to probably take that opto off or move it off the board there a little bit, bend it up, and then connect onto it, and then feed our modified signals back into the board just here. So that's one way of modifying the voltage. I don't see any reason why the motor control module won't accept a modified voltage, so that does mean that you could run the HCH2 inverter at a higher voltage than it's probably spec'd for. Anyway, so let's just go back to looking at what we've got here. At the moment we've got a voltage of 15 volts on the IGBTs, and if we look at the display here, we can see it's telling us 1536, so if we call that 15.36 volts, so that's pretty reasonable. It seems to be like a 16 bit number there. So if I turn on my power supply, this is the only power supply I've got at the moment because my variable one is broken. This will supply us 200 volts on 196, 197 volts, as you can see here. So if we go back over here now and look, we can see we've got a voltage of 197, 197, 198 there. So that's the voltage that's being spat out on the CAN bus, on the IMA CAN, and that's the voltage that's being passed over the serial data to the motor control module. So that would be the voltage that we would modify. Now I'll just undo that. So if we look at the innards of an inverter, so under this printed circuit board here, we have the three IGBT modules. This is where all the work goes on. So if I flick this one up, this is one I've murdered earlier on. Let's try and take this off here. There we are. So basically from the high voltage side of, well, the input side of the IGBTs, there's a positive and negative on each of these IGBT modules. So these are for each of the three motor phases. There's a 480k sequence of resistors, which then feed into the top of this printed circuit board here. And so by introducing a pull down or a sort of potential divider, you'll see here I've got, you might be able to see, I've got some little resistors here. And if we connect these resistors across the input into the printed circuit board here, these are about 180k, and the original was the input from the IGBT is about 480k, something like that. But you do get a reduction in voltage. So if I was to connect those resistors to these two IGBT inputs here, then this sends out, this module here sends out a lower voltage to the motor control module. So you can either hack it using a serial man in the middle type device, or potentially with fixed resistors on the three IGBT voltage sense inputs. That's probably going to be the simplest, but for maximum flexibility and to find out where the limits are, I'm probably going to go with a serial device, man in the middle type device in that part there. Anyway, if you just go back and look at the IGBTs, you can see this is where all the power goes. There are massive amounts of current for our IGBTs, and I think these have failed in the past on the HCH2. Hopefully that's not a common thing, I'm not aware of it being super common, but obviously I've got quite a few spares here, but it is a bit of a pain because you have to desolder them all from the circuit board to get at them. You can't get at these very easily at all because they're obviously all underneath. This obviously one is no good anymore because I've hacked the printed circuit board off it to see what it makes it tick. But there you go, so that's what I'm doing at the moment, fiddling around. I'm now going to make a serial device to go man in the middle, and we'll see if we can make an adjustable device here to turn the voltage down that the motor control module sees. And then once we've enabled voltage hacking on the HCH2 inverter, then we go back to the HCH2 battery control module, and as we know, we can fiddle the inputs to this just by using a simple voltage divider resistor matrix, and that way you can turn down the voltage that the battery control module sees, so that the two will then match, and then you shouldn't really get any error codes as regards voltage, and that allows us to put very high voltages on and hopefully get a lot more power without too much more current. That's where we are at the moment.